This Ugandan farm operates through a network of specialized zones, managed grazing fences, an isolated dairy unit, and elevated storage silos. Welcome to Yaka Digital Network explainer videos. Farm buildings are often constructed with the singular goal of keeping livestock and equipment out of the rain. To reach high yields, these structures must function as active environmental control systems, engineered to manipulate airflow and isolate biological waste from the herd. We will analyze how site selection, the properties of local building materials, and internal zoning optimize animal health in the Ugandan agricultural context. Treating a building as a passive shelter leads to biological failure. Designing it as an active system is the requirement for biosecurity. The engineering of a biosecure farm begins before a single brick is laid. It starts with the topography of the landscape. This topographic grid illustrates a structural hazard. Building in a low-lying valley ensures floodwater rapidly pools at the base, concentrating pathogens near animals. Choosing an elevated slope allows gravity to pull rainwater safely away without mechanical pumps. This site must also maintain a strict distance from natural water sources. This prevents waste runoff, especially from high-volume operations like piggeries, from contaminating the local water table. Even on high ground, moisture can rise through soil. To prevent this, builders install a hardcore subbase of broken stones. This layer breaks capillary action, draining moisture laterally. Finally, a solid concrete layer creates a complete moisture barrier. Because concrete is non-porous, it can be scrubbed and disinfected. This breaks the transmission cycle of soil-borne pathogens that thrive in dirt floors. The foundation acts as the farm's initial physical barrier against disease. Moving upward from the foundation, the selection of wall and roof materials must balance durability against biological threats. This comparison shows wall vulnerabilities. On the left, traditional wattle and daub walls degrade, allowing termite intrusion. Preventing infestations in organic materials requires constant maintenance. On the right, burnt bricks and concrete blocks remain stable, repelling pests while providing strength. The roof protects the internal environment, but the material choice can introduce new hazards. Thatch grass is cheap, but it harbors insects and poses a fire risk, making it unsuitable for high-hygiene structures. Corrugated iron sheets are the standard choice. Their overlapping design repels the heavy water volumes of Ugandan tropical rain systems. Iron sheets also facilitate rainwater harvesting, turning a weather event into a source of water for cleaning and livestock. The building envelope converts passive weather defense into an active resource harvesting system. Inside the facility, the design focuses on specific biological needs. In a dairy barn, the priority is protecting milk quality. Concrete floors are mandatory here to prevent the spread of mastitis, a bacterial infection of the udder that thrives in damp, unhygienic conditions. This blueprint shows how spatial zoning improves management. Separate areas are designated for lactating cows, dry cows, calves, and a dedicated milking parlor. The milking parlor acts as a contamination-free zone, keeping the milk collection process isolated from the living areas of the herd. Designated feeding and watering zones reduce waste. Additionally, roof and wall dimensions create continuous drafts. Blue vectors show air pulling heat, humidity, and ammonia gases away from cattle and out through ventilation channels. Dairy architecture is an infection control system built around the mechanics of the milking process. Poultry houses must accommodate birds' high sensitivity to temperature and respiratory issues. This cross-section shows the required airflow. Dense wire mesh walls allow drafts to cleanly pass through, removing ammonia buildup from birds' waste. The mesh also serves as a physical barrier, blocking predators and pests from entering. Concrete flooring is used here to support the rapid sanitization required between every new flock. Controlled lighting structures are used to manually regulate the laying cycles of egg-producing breeds. Lower-cost timber framing is acceptable for these structures, provided the wire mesh and iron roofing remain secure. The final design provides the high-volume air exchange birds need for respiration, while physically blocking the entry of predators and pests. Piggery architecture must manage high volumes of waste and mitigate the animal's vulnerability to heat. This sloped floor uses Clasity to pull liquid waste into a drainage channel, keeping sleeping areas dry and hygienic. Additionally, because pigs cannot sweat, a high roof allows heat to rise away and vent out the top. Internal pens provide necessary separation, isolating farrowing crates for sows and piglets away from the grower pens. Walls must be made of durable concrete or brick to withstand the strength of the pigs and allow for the heavy scrubbing needed to control viruses like African swine fever. Floors are left with a non-slip texture to prevent injury, while the entire structure is secured to prevent escapes. Piggery design relies on gravity and thermal airflow to maintain hygiene. Livestock housing is supported by a network of storage and utility structures. Forage stores and granaries isolate feed from moisture and rodents during the off-season. Fencing allows for rotational grazing to manage pasture health, while workshops provide space for machinery maintenance. Look at these two structures, a grain silo on the left and a cattle dip tank on the right. Which one prevents moisture and rodents, and which one controls ticks? The grain silo is designed to provide a dry, sealed environment for grain protection and spoilage prevention. The dip tank is used for livestock health management, specifically for tick control and medical examinations. Agricultural success relies on matching the biological vulnerabilities of your livestock with the physical properties of your building materials. You can watch more videos for all of your agricultural classes right here and get all content at www.yaka.cc.